Hi everybody, back to making stuff with Mr. Hoon. Right here in Mr. Hoon's home, his studio. Family's downstairs, youngest daughter's doing work from home, Google Classroom, like you should be doing. If you haven't signed on to my Google Classroom in Intro to Art, for example, this is a video dedicated to Intro to Art. We're going to pick up where we left off on linear perspective. Please sign up if you haven't already. If you need help, email me. No problem there. I'll get back to you as soon as I can. Well, just to recap, we're exploring linear perspective. We're building on what we know. We're doing review right now. We're working on 1-point and 2-point perspective. In Google Classroom, I put a great video link. It's very short, and it gives you some sense of where linear perspective evolved in Europe and some of the geopolitics that were involved in the rise of the Renaissance. I'm not going to hammer you on that. In my first video, or in my second video, I gave you my views on that. Please watch that video and answer the question, if you'd be so kind. So let's get back to actually drawing. Remember, the Renaissance in Italy, in Northern Europe, was rediscovering the ancient Euclidean geometry, Euclidean mathematics, and of course, after the conquests during the Crusades, the back and forth, the cultural back and forth between Islam and Christianity led to an exchange of information. And then we have in Europe, Eurocentric, remember, the rise of the Renaissance and the rediscovering of science. So here we go. I'm going to take a moment, switch this over. Let's start some drawing, shall we? So here we are. As you can see, the drawing looks more resolved since the last time you saw it. And one reason for that is, after my introduction, I switched camera views and they did a whole lesson on how to draw a floating 2-point perspective prism and a stationary 1-point perspective prism. Plus, I taught adding a light source in the sky, dropping below the light source, and then putting a dot on the horizon directly before the light source. Now, I'm obviously re-recording this because the first recording didn't take, so I'm going to do it again. I'm going to show you all how to draw a 2-point perspective, linear perspective box floating in the sky, a 1-point perspective box on the plane, on the ground, and how to cast shadow, show you direction of shadow and length of shadow on that 1-point box. And hopefully the video will take this time. Let's hope. As always, I'm using light pressure and a sharp pencil. Keep your pencil sharp. This is an H pencil. Now I'm going to be drawing with a little bit more pressure so you can actually see the lines. If you get to a point where there's so many orthogonal lines that help us determine direction, shape, size of these this illusion of three-dimensionality, then erase them, okay? But if you're comfortable with them being there, that's fine. We'll cover them up with shading values, and we'll do some erasing later. Today is not the day. So you'll have a lesson from me today. We'll finish up on Friday, and hopefully I'll be seeing lots of more examples of your practice coming in on Google Classroom, along with your response to my question about that short video on linear perspective in the European Renaissance. So give me your thoughts, post it to Google Classroom. If you're struggling with that or if you don't have access, let me know. You'll notice in Gradebook that we're taking it really slow. We're not even entering grades until April 7th, but you'll notice that I will post at least the assignment on Friday. And that assignment is a way for you and your parents or guardians to check what the expectations are. Also, Google Classroom, I'm hoping, is coming across clearer and clearer in terms of what expectations are every single day. That's right, let's get back to drawing. So here we have the illusion of depth on a flat surface using linear perspective. Now, one thing I'm noticing is that the video is improving slightly. And what I've been doing, since I did receive some feedback about poor video buffering, is I'm reducing the amount of pixels per square inch in an effort to lessen the amount of data that the processor has to process to get that digital information to you. I'll be tinkering with this, watching my own YouTube videos, and asking experts on what they recommend as YouTubers. So let's get on with it. I'd like to create a floating 2-point perspective box, and obviously I need vanishing point 1, vanishing point 2 to do that. I'm going to need a ruler. I'll put mine rather high in the sky, and that rhymes. And I always start with my leading edge, my corner. Boom. It's going to be tall like this one, tall and vertical. To create the sides, I'm going to make certain that my ruler is attached to vanishing point 1 and the top of the object. I can get comfortable to a point where I no longer need to even draw the actual orthogonal line all the way. When you get to that comfort zone, you can just draw the orthogonal to describe the edge that you want instead of going all the way. But some of you will want to continue to draw that orthogonal all the way to the vanishing point every single time, and then erase those orthogonal lines later, those descriptive lines. So what we do on one side, we do on the other. Boop. Boop. What we do on one side, we do on the other. Always line it up with the vanishing point exactly. Otherwise, you will have slight inaccuracies. Now we have this arrow shape moving up. Now we are at 2, 4, 5 lines. We know that in a 2-point perspective box, we need 9 lines. So let's include our next 2 to make it 7. They're parallel verticals and show the thickness and depth of the box. They must be parallel to the corner, the leading corner of the box, to look accurate. Otherwise, you're going to have inaccuracy. Now there is something missing, It's the bottom side of the box. You know, we've got this side that's visual. Can't see the top because our eyesight's below the top of it. Our horizon line is our eyesight, eye level. We can draw in the box, but the diamond shape of the box is going to look different based on how high it is in the sky or how low it is on the plane. So, here we go. We'll go with the opposite, farthest opposite to vanishing point 1. Cross it over. And we'll repeat the process with the farthest opposite corner to vanishing point 2. And repeat the process. And there we have this object that later we will be adding values, meaning shading, tinting, to these objects as they relate to a light source. Now, as you can see, I've created a light source up here already. It's very important that you understand that we don't use our vanishing points for the light source all the time for direction. We use a point directly below the vanishing point, and wherever that, we use a point directly below the light source that lives somewhere on this horizon line. If the light source was over here, we drop a little plumb bob down and we'd mark it here, and we'd use that point of light origin to determine the length of our shadow, the direction of our shadows. Determining the length of the shadow has to do with the light source itself. But I'd get ahead of myself. Let's put a 1-point perspective box right there, okay? And then we'll deal with this whole shadow business. First thing I'm going to do, and forgive me, I need to tilt this my way a little bit. I know that it's a little bit of a challenge because of how my video is set up. All right, move this over a little bit so that I can sketch more effectively, hopefully. Okay. I'm going to create a box, a square, all right? A square. 4 equal sides, approximately. And I'm paying attention. I made a mistaken line there. I want this to be, I want these lines to be parallel. These lines, the verticals should be parallel to the side of the page. The top and bottom should be parallel to the top and bottom of the page. Then this is just one face of the 1-point perspective box. Now we need to show the sides of it. So we'll take each corner of the square and send an orthogonal back to its central vanishing point. Remember, we put that 1-point perspective vanishing point in the center of the horizon last time. They're all emanating from the center. And that even goes for this really skinny, shallow area right here. From this corner, we need to pick that corner up and send it back. All right, now I'll do what's called reinstating the line. Instead of getting all freaked out and saying, oh man, I screwed up like I did here or even here, I'm just going to reinstate the line where it seems accurate and leave the mistakes behind. And if I do that, I'm not going to waste so much time with erasing all that, because we're going to be covering this up with all kinds of values and tones and shades and tints, and many of these mistakes are going to fade away. All right, now we have this side and this side. We simply need to determine how deep our box is. So I'm going to choose, I'm the magician here, and so are you. You get to choose how wide or deep you want your box to be. Reinstate the line. All right. So here we are. We've got this drawing. We've got 2-point perspective, rectangular solid floating. Got a couple of them. We've got 2 floating 1-point perspective rectangular solids. Now we have 2 stationary, anchored, if you will, 1-point perspective boxes. Just like I did here in creating a mathematically correct cast shadow based on the light source, I'm going to teach you that here. And we're going to call it quits. In our next session coming out tomorrow or Friday, I'll add maybe a cone, a sphere, a cylinder. We'll shade it, and we'll be done for the week. Then we'll move on to 3-point perspective next week. Yeah, and then it'll get serious. Right on, man. Let's think about this. Got a light source up here. You need to put little sunbeams and rays here. You go right ahead. For me, I kind of have the direction. It's almost like a clock. I've got a direction for this. Now it's coming down here. But remember, to show direction of shadow, you need to bring a dotted line. It doesn't have to be dotted, but you got to know make a point on the horizon that is directly below the light source. Light source, point of light origin. I'm going to call this is Mr. Hoon. This is Mr. Hoon's invented term. Point of light origin. Or perhaps we should call it shadow direction origin. Shadow direction origin. And I'll show you why in just a little bit. Shadow direction origin doesn't tell us the length of the shadow. Yeah, it's right in the name. It tells us the direction of the shadow. So what we need to do is take our ruler from shadow direction origin point and pass it through the closest 3 corners, or whatever corners we see. Now, we don't know how far it's going to go, so your guess is as good as mine right now. So we're going to put them down there like that. Maybe it's going to be even farther. Maybe for this one, it'll go right behind this box. We don't know that. We don't know that. So to recap, light source. Origin point for shadow direction, which is directly below the light source on the horizon line. Origin point casts orthogonals through the closest corners on the base of the object. So we've got the direction of the shadow based on the light in the sky, but we are missing the length of the shadow. And instead of using the origin point for direction, we're going to use the light source itself this time. Now, I'm going to start in the middle because I can see most of it. And all I'm going to do now is go from the center of that light source, attach it to some point where it's going to meet this line. And I think that meeting point is going to be right there. Now this, my friends, it is probably going to freak people out a little bit. So I'm going to take it slow. Take it slow. From here, from the vanishing point for 1-point perspective, to here, we're going to create a line. Now we know on this side of the solid, that's where the shadow is going to live. We know its direction, and we know how far it went. However, what we don't know is this. We know the direction of the shadow this way, but we don't know how far it's going to go. So we've got this side, but not this side. Now, because this is horizontal, it makes sense to me that I'm either going to use this vanishing point to adjust its length, or I am going to make a parallel line to adjust its length. And in this case, because this vanishing point is so far behind this object, I'm going to use just a horizontal line, just like the bottom of this, to describe the shape of the shadow. Now later on, we're going to fill in more shadows. We're going to use our technique of using the light source for the length of the shadow, the direction line for the direction of the shadow. But right now, I want to finish with this 2-point perspective box sitting on the plane, P-L-A-N-E, a surface. And we're going to cast its shadow length, and we're going to determine its shadow. I'm sorry. We're going to cast its shadow direction. We're going to determine its shadow length using these techniques. So here we go. All right, we've got 2 boxes. Look at how they seem to be kind of anchored on the surface now. That's good news. All right, with the 2-point perspective box, we have these 2 points of vanishing points. They're going to rule, they're going to help us determine the direction and length. But let's not forget about, yes, this guy right here. Shadows are complex, kids. Shadows are complex. So we have to determine, are we going to do it, just suggest the direction and just use our vanishing point and continue this orthogonal out? We could do that. That'd be a good estimate for if you were drawn and you were just estimating. Or we could get a little bit more precise and use the origin point below the light source and use that to determine our shadow. So here's what I'm going to show you. I'm going to show you a little, I hate to use the word trick, but it's going to make the shadow look more convincing. I will continue this bottom orthogonal pretty much off the page. And it vanishes at 2. This bottom orthogonal vanishes at 2. Now, I will go through the farthest corner here, vanishing at 2, pretty much off the page. And we know that's going to be pretty much the direction of the shadow coming from the light. We don't know how long yet, but that's pretty much the direction of the shadow. Now this shadow, this cast shadow is going to be really dark compared to what I'm about to do now. And that is, this time, I'm going to pass from the direction origin, below the light source, with an orthogonal, imaginary one, stopping right there at that corner, and then continuing on. So you can see that there's a thin triangle here of shadow that's going to be slightly lighter than this humdinger here, which is going to be pretty dark. Now what we don't know is, this is a big box compared to the picture plane. What we don't know is how long the shadow is going to be. In order to do that, we use not the origin direction point, but the light source itself. And we pass that orthogonal line through the top closest corner, and look, it goes off the page, and it would meet the shadow somewhere down here. And we do the same thing here, and look, it goes off the page, and it would meet the shadow somewhere down here. So what we have is an accurate direction. We even have a more complex cast shadow, because not only is it casting shadow right along this orthogonal that vanishes at number 2, It's also casting shadow from the rectangular solid from this direction origin point directly below the horizon line. So it's kind of a multifaceted, multi-characteristic shadow. And the more characteristics, the more values, angles, refraction, bending of light, reflection of light that you add to a shadow, the more convincing it becomes. So, direction of shadow, length of shadow. That's what we're talking about here. And in the future, we're going to be talking about estimating where shadows might cast on the plane, shadows from these objects that are floating. And that'll be fun. So yes, this is a learning curve for most of us. But the only way that we get better at it is by trial and error, by experience. Are you with me, humans? Right on. We're going to add more things. I'm going to put a cone right here and a sphere here. Put a cylinder in the distance. Shade and tone that whole sucker. And we'll be good for Friday, man. And then we'll move on to 3-point perspective. You know, thanks for working with me. I miss you kids. Miss talking with you, laughing with you, listening to your stories when you're working, sitting next to you, answering questions. But we're going to get through this. We're going to get through this as family with our families. We're going to get through it through our community. We're going to get through this challenge to our culture, our society, this world challenge of COVID-19 together with patience, with love, with empathy, with respect, and hopefully a little bit of creativity because it's good for the mind, the body, and the spirit. And I'm not just saying that because it's some cliche statement. That's a fact, Jack. I miss y'all. My thoughts are with you and your families. I hope you enjoy. And let's keep making stuff together. All right? Mr. Hoon, out.